Hello everyone. Today we will study relation between alpha, beta and gamma. In the previous videos, we have seen that alpha is thermal coefficient of linear expansion, beta is thermal coefficient of areal expansion, and gamma is thermal coefficient of volumetric expansion. Now we will find the relation in between amongst these. So first of all, take a rectangular sheet whose length is 1 meter and whose breadth is also 1 meter. Now we will rise the temperature of this sheet by 1 degree Celsius. So rise in temperature (1 degree Celsius). So there will be thermal expansion in this sheet. So this length will be get increased as well as this breadth from this side also. So there will be this much expansion in this two-dimensional or rectangular sheet. We define this expansion in length by alpha. Why? Because in the previous video we have seen that alpha is thermal coefficient of linear expansion. When we take 1 meter length or 1 meter rod and we rise its temperature by 1 degree Celsius and the expansion increase in length, that is denoted by alpha. So this expansion is alpha, and this expansion in breadth will also be alpha. So will the expansion will be from this side also? Not from this side. No, it will be from both the sides. But for the convenience, we have taken all the expansion in this side. So now before expansion, the original area of this sheet, (1 meter in length and 1 meter in breadth). So it will be equal to 1 meter square. And area after expansion, which we can express as delta A, that will be equal to length. What is total length now? That is 1 plus alpha. And what is breadth? That will be equal to 1 plus alpha length into breadth. And this will be the length 1 plus alpha, and the breadth will also be 1 plus alpha. This is the new area and minus the original area, that is 1 meter square. By this we can find the expansion in this area due to temperature. It will be equal to 1 plus alpha square minus 1. That will be 1 plus alpha square plus 2 alpha minus 1. We can cancel this plus with this minus 1. Alpha square is very small value, because alpha even is very small expansion. There will be very small expansion if we rise the temperature by 1 degree Celsius of 1 meter length rod. Alpha square is very small, so we can neglect it. So this delta A will equal to 2 alpha. And now we will find beta. Beta, that is, we have defined the definition of beta in the previous video, that is equal to change in area upon original area into change in temperature. What is change in area? Change in area is 2 alpha. We have defined it here. Original area is 1 meter square, and change in temperature is 1 degree Celsius. So beta will be equal to alpha. So this is the relation between alpha and beta. That is, thermal coefficient of aerial expansion will be equal to 2 times of thermal coefficient of linear expansion. Now we will find the relation between gamma and alpha. Gamma is thermal coefficient of volumetric expansion. So there will be expansion in volume. So we take here a cube. Whose length, breadth and height will be 1 meter. This is 1 meter, 1 meter, 1 meter and 1 meter. As we rise the temperature of it by 1 degree Celsius, rise in temperature by 1 degree Celsius. So there will be expansion in this cube in its length, breadth and height, and it will be equal to, we have seen that it will be like this. This expansion will be equal to alpha, alpha, alpha. We have seen it that it is thermal coefficient of linear expansion. Okay. Now, as we have seen when we finding beta, this is almost, so expansion will be alpha in 1 meter load length when we rise the temperature by 1 degree Celsius. Though this will be the expansion. So rise in temperature by 1 degree Celsius. So what will be the original volume? Original volume of this cube, that is cube of side, and it will be equal to 1, 1, 1, 1, that is 1 meter cube. Now after expansion, its volume will be equal to 1 plus alpha. Thus its length has, this is 1 meter plus alpha, 1 plus alpha, length, breadth and height, and it will equal to 1 plus alpha cube. So 1 plus alpha cube will be equal to 1 cube, 1 ka cube plus alpha cube plus 3 into 1 into alpha into 1 plus alpha. So it will be equal to 1 plus alpha cube plus 3 alpha plus 3 alpha square. This is the expansion after rising temperature of cube by 1 degree Celsius. Now difference in the volume before raising the temperature or after raising the temperature, that will be equal to 1 plus alpha cube plus 3 alpha plus 3 alpha square. And what is the original volume? 1 meter cube. We will subtract this from this expansion. So we can cancel this 1 with minus 1, and alpha cube and 3 alpha square can be neglected because these are very small. Alpha is very small quantity, and square and cube of it will be more smaller, so we can neglect it. So our change in volume will be equal to 3 alpha. Now thermal coefficient of volumetry expansion. You have seen the formula of it, that is change in volume by original volume into change in temperature. So change in volume is 3 alpha, original volume 1 meter cube, and rising temperature 1 degree Celsius. So gamma is equal to 3 alpha. So this is the relation between alpha, beta and gamma. We have found this relation. So we can write alpha equals to alpha, in beta equals to 2 alpha, and gamma equals to 3 alpha. So this is the relation between alpha, beta and gamma, that is thermal coefficient of linear expansion, thermal coefficient of volumetric expansion, and thermal coefficient of aerial expansion. So it is end here. Thank you.